Well, you heard the young Kursinski talk. Now we got a real Kursinski current day. Yeah, this is the version 30 years later. I was quite young looking. I see in those pictures, but I've actually got one picture that's even younger, and it's not an embryo. There was some time. Okay, so let's see which that. Okay. Oh, so this is what Rick asked us for. I'm going to try and say some words. I'll overlap with some of the things Tom said, my perspective, but it's pretty similar. So one of the things I wanted to say, Rick mentioned this. So I actually started in RO quite a bit earlier than GPS Met because of Voyager. So I started working on Voyager related stuff in 1981, and I was involved with the Voyager RO measurements of Saturn, working for the DSN. Then for Uranus, I went and worked for Voyager. And then Neptune, I actually wrote the requirements for the Neptune encounter and then changed jobs so that I could implement the requirements that I had just written. So I knew exactly what I wanted. So very nice. By the way, this is a picture. This is from the 1986 Voyager Uranus encounter. That's me in the center. Ed Stone, who was the chief scientist of Voyager, just died this year. And so I was looking at the movie and I said, I'm in it. I saw myself for a split second. So I snapped this. And that's Len Tyler in the foreground. He was the head of the Voyager radio science mission, and that's Stanford. That's the connection that Rick was saying. He was one of several people at Stanford that were absolutely critical. And this is where I learned a lot. I learned the engineering from the instrumentation from JPL, but I learned the theoretical stuff from the Stanford side. Yeah, and so after 89, after the Voyager Neptune encounter was in 89, I was looking around for what to do, and that's when I learned about GPS MET and GPS occultation. And I knew enough that Ab Davis hired me to be the system engineer on this GGI instrument, which is the Tom Young paper from 1988. I assume everybody sort of know that's the first paper that said you can do radio occultation. In fact, C.H. Liu was a co-author on that paper. That led to the where it was documenting what the GGI was, which was this geoscience instrument. And Melbourne actually Bill Melbourne, I think actually mentioned it in that little blurb from the 1991 meeting. And then I entered, I wanted to learn the science side. I got into Caltech and went to Caltech. And as it says there, I did my PhD on the GPS radio occultation technique because it turns out Earth is a planet too. So they allowed me to be in the planetary science department and do that. Yeah, okay, so from my perspective, GPS MET was actually a latecomer because we went through radio occultation, went through every other planet in the solar system, and then finally got to Earth in 89. So as Rick said, it started in 1965, way before my time. And Voyager, marched through well, Pioneer 10 and 11 saw Jupiter and Saturn first, and then Voyager saw the outer planets as well as Titan, which was an amazing mission. I'll just mention the radio occultation predictions for Titan were challenging because the uncertainty in the surface pressure was 1 millibar to 1 bar. It was a factor of 1,000 uncertainty because it's a nitrogen atmosphere and they couldn't see it spectroscopically. They could see methane was there, but they had no idea. They knew something else was there. And so the predicts were a bit of a challenge. And they did some very wide bandwidth recording to make sure they caught it. Yeah, in fact, the only planet at the time, the only planet that hadn't been visited was Pluto, and it's now no longer a planet. So Earth was actually the last one. So yeah. So this is an interesting thing. I did not meet Tom, but this is where I learned about GPS for the first time, was the Voyager Neptune encounter. I was down in Australia at the time, but we had three antennas we were using. We're using the big DSN antenna, which is 43. We're also using a Parkes X-band radio observer. I'm pointing off to the right. But we're also using this big antenna in Japan. And so Voyager went by Neptune, and then it went by Triton. And what happened was, we had decided, NASA threw a fair amount of money. This was a once-in-a-lifetime encounter. So they had a lot of money that they threw at this encounter. And one of the problems was, what's going to happen if the ionosphere does anything weird over Usuda in Japan? And so it's like, I don't know, we've only got S-band. We don't have dual frequencies. So somebody came with the idea, let's get GPS involved and have them do measurements over Japan. And I said, okay, I'm not sure we'll ever be able to calibrate because it's not the same line of sight, but sure, somebody seems to have money, let's do it. Turned out to be god-awful important, because in between the Neptune encounter and the Triton encounter, the signal level measured at Usuda started oscillating unbelievably strongly. I mean, 20 dB oscillations. And everybody's going, what in the world is that? Because then they're thinking the preamp, the amplifiers are going unstable. And so we're scrambling, and Usuda's starting to say, well, we could shut this amplifier off. We could bring this one up. We might have enough time. And then Tom, I don't remember how you told us, but he said, I'm seeing the same thing on the GPS signals in that direction. And that's when we knew, oh, it's the stupid ionosphere. Well, some people would say, it's great that the ionosphere people are probably going, that's a great storm. Well, it's like, do your storm somewhere else at a different time. This is not the right time to be doing that. And luckily it died down, and by the time the Triton encounter occurred. And I never actually met Tom there, but I know you and Larry Young went over there. And the other thing is, the equipment that they brought over, what I was told, I never saw it, was a rack of equipment. And that was the Rogue receiver. And then what Tom was just showing up here was the Turbo Rogue, where all that stuff was miniaturized into a small box. But anyway, so I actually, this is where it started, where I started to learn about GPS. And also on the lower right, I'll just say, this is also where I learned about the frequency and timing stuff, and the three-cornered hat method that Rick has been using, Rick et al. Have been using. That's when I learned about it, because that's how you measure frequency standards. When you get standards that are all equal and state of the art, you take three of them, and you can actually figure out what the relative stabilities are. Okay. So this is the GGI. I started working on GGI. The point I wanted to make here, we had funding from NASA to do some of the initial work on the development of the GPS radio occultation receiver. And it's interesting because EOS, Tom Young kept telling me the reason NASA chose it was not because of the occultation, it was because it was an altimetry support instrument just to do precision orbit determination. And and then it ended up getting canceled in 1992. And it never flew on the other satellites. I mean, it was going to fly on an altimetry mission. And then as that was canceled, I went into Caltech. I'll just say that was an exciting time for me financially. We're all talking about financial issues. That was what was supposed to be funding me while I was doing my PhD, and the money was gone. So I spent the first semester writing my first proposal to NASA to get myself self-funded. And just to add a little bit to what Tom was saying, it was a little exciting in the sense that when NASA got the proposal, they sent it to UCAR for review. And Mike Exner said, no, we don't need it. We're building our own retrieval system. And it's like, oh, that's a good answer for me. And what happened was Bill Melbourne said, if you want JPL participating in this, you're going to tell NASA you want them to fund this proposal. And then Exner said, okay, yes, we want we want NASA funding that. So, and these are the realities of getting this stuff up and running. I just listed some quick things here. So we got the funding. One funny thing here in the big bullet up there. So George Hodge and I sort of put the retrieval system together at JPL. And that's why, by the way, why there's two retrieval systems. There's a UCAR system and there's a JPL system. This is where those things started. So the high tech of the period. I mean, you saw the slides we were putting literally view graphs. I use that term every once in a while, and people are going, "What do you mean a view graph?" It's a piece of plastic with printing on it. You put it on a projector, and you see. The high tech aspect was George and I each got a second phone, so that we could talk to each other at night and be dialed into JPL and run some code. So, and the other thing I remember this, where I said that, George's wife said to me at some point, "Can I have my husband back?" Because we were just so involved trying to get this thing running, with the launch. I just mentioned some things here. We did figure the bit about the non-spherical shape of the Earth, which had been a problem at Jupiter. I remember figuring out what's the coordinate system. ECMWF has its coordinate system. We have a geometric thing, and learning that the geoid was defining the bottom of the ECMWF system. As Tom said, we worked on the open loop, this flywheeling thing. I didn't realize you had so much already done beforehand. But that's a picture of the depth of the penetration, that when we did the flywheeling, it really improved the depth of the occultations. Double differencing, horizontal motion of the ray path. And the other thing that was really important was this paper by Vorobev and Krasilnikova that figured out how to do the ionosphere correction, interpolating to the impact height and doing the correction on the impact height. Simple idea, but no one else had thought of it. It was really critical. And this, of course, was the results that we published in Science in parallel with Stick Ware's paper. I'm coming from planetary. John Eyre got very excited about this, so I said, "This must be good." And those are some of the first profiles we generated. Oh, and Vern Sumi, I'd forgotten about him, but he was on his deathbed and was asking for profiles because he wanted to see if it was real. And I remember Sanjay LeMay saying, "Please get us a profile if you would." I'll just say it took a while to recognize the power of GNSS-RO, because at JPL there are these giant instruments and kingdoms associated with these giant instruments, and we're this weird little GPS instrument, and Moose Shaheen. The Machiavellian issue at JPL for us was Moose Shaheen. He saw this as a threat to the Ayers empire, and I mean, Ayers is a fabulous instrument. I'm just saying he was saying, "You're not, this JPL is Ayers territory," kind of thing. So it was a real problem. It was very hard for us to get funding because he was the chief scientist. In fact, various people tried and they said they'd never seen him respond like that to anything else. But like I said, John Eyre thought it was great. So, and then a lot of my thesis work at Caltech was on the accuracy because people were questioning. So this is the last stuff. I put that shutting the AS off. I didn't know how that happened. I was sort of wondering, but it was what Tom said about Topex. But that was amazing that JPL somehow was able to get the Air Force to shut off that. I'll just make these quick points. GPS-MET demonstrated that RO could be done on the Earth with GPS, using GPS as sources. It demonstrated this unique and very powerful combination of very high vertical resolution, precision, and accuracy with global coverage. And then from my standpoint, the key thing about COSMIC was it demonstrated with 6 satellites, you could do it operationally and have real impact on NWP. And I'll just mention, I remember when Sean Healy told me when he turned on the COSMIC data the first time, I forgot to put this in here. What happened was the aircraft bias, temperature bias shifted. And Sean's response was, "What the hell have I done wrong?" And then the aircraft people came down the hall going, this is his description, they came down the hall going, "How did you find the aircraft bias, the temperature bias?" And then Sean explained it, and it's like, and that was when COSMIC really took off, because once people saw that correction, they went, "Oh my God, this is real." So anyway, that's it. That's it.
Okay, we all heard very interesting histories. And now I would like to invite the following individual who was key player in the GPS MET to be joining us on a panel that include Bill Schreiner, Sergei Sokolovsky,